Hello, ladies and gentlemen. I finally put all my brick maps into a single dynamic vertex buffer and a single dynamic index buffer. What that means is that I have 32,768 little cubes, and all of those contain 8 by 8 by 8 cubes, little voxels. If I zoom out here, I just generated it all. I just populated all the brick maps in the chunk with noise. Some of them are invisible, some of them weren't intersected with noise. And then I generate meshes for each of them. And when I greedy mesh them, I try to see if any of their adjacent brick maps are either like in front of the face, and if they are, then I don't render them, but I still submit draw calls for them, so you can see that even if I full screen it, I get up to 40 frames per second, but it's really not that good. I'm running on a 3080, so it really should be better. But it's a great start. I wasn't able to do this before. I was using a dynamic vertex buffer for every brick map individually, which hit the limit for the BGFX API. The BGFX API has a limit of 4,096 dynamic buffers, and so if I was using one for every one of my brick maps, I would hit that easily because I have like 32,000 brick maps. So I put them all into one dynamic buffer, and then I update them all individually and generate meshes for them. And then I submit a draw call for every single one. So I'm submitting 16,000 draw calls because even though there's 32,000 brick maps total in a chunk, I only need to render like 16,000 of them because those are the only ones that were touched by the noise. So it could be a lot better, but I've already made some improvements. I was running at like 30 frames per second earlier today, but I was able to get around that I was being really stupid. Every time I populated a brick map with noise, I meshed it right there. So, of course, there weren't any neighboring brick maps yet, so every single one would be rendering all of its triangles. But I can show you, it's not perfectly greedy meshed still. There would be way bigger cube faces here that are just single triangles, but you can see that there's just strips. So it's kind of semi-greedy meshed, but at least you can't see anything inside. There's still a lot of lines because I'm instance rendering all the visible brick maps, or all the brick maps that have been voxelized, so I can still improve on that. Like, I can just have a little bool inside the brick maps that just flips whenever I detect that there is valid vertex data in whatever buffer that it has. And they all have these little let me just close that down. You can see it generates 1 gigabyte of memory, which is not good because I'm being very naive with how I populate the arrays. I have this helper struct, brick map mesh helper struct, that contains these arrays that I populate. They never change size, and each brick map in the dynamic buffer has a stretch of memory that never changes or adjusts, so I'm being very naive. I never shrink them down, so I could use vertex packing, vertex pulling to shrink the size, but right now it's just static, just to get everything working. You got to build these systems very stupidly, very, very naively, and then you can optimize from there. And now I finally have it working, and it's running at 40 frames per second, and I'm not optimizing anything yet, and there's a lot of room to improve. I have a 3080, so I would like to try and get back to 144 frames per second like I was before. So that's pretty much it for today. So lots of nice progress. I'm happy to finally get it working. Thank you, thank you. Hello, ladies and gentlemen. It is September 6th, 2024. Let me get all these windows in place. Yesterday I finally got a single chunk rendering, a single 256 by 256 chunk rendering. Today I spent the day determining which of those chunks were visible or not. We can start voxelizing all the chunks right now. It's empty, as you can see, but we're generating it. It takes like 15, 16 seconds. We have a i7 CPU, so we have a rather fast CPU. We have very high-end hardware, so the next thing I need to optimize is the chunk generation. But, if I multi-thread it, it'll probably be okay, even on today's system. So I can full screen it, and you can see up in the corner we're up to 100 frames per second, which is incredible. And then I can even, well, here I can show you the triangle meshes. Yeah, so We're now completely greedy meshing all the completely filled brick maps, so you can see that it's just single. These are all brick maps. They're 8x8x8 cubes, and so I just turned that entire face into 2 triangles for that quad. And so we also check if the brick maps are visible or not. All the brick maps in here, they're not visible, so we're not drawing little cubes for them. And you can see right here, we're only submitting 5,445 draw calls per frame. We have a 3080, so, you know, I think anything above 1,000 draw calls is completely retarded, and you don't want to do that. But this is rather unoptimized at this point, so it's okay. But I can even toggle that further, and we can toggle the brick map visibility. And OBS is capturing the frame, so it's not quite at a stable 164 frames per second, but whenever we don't render all the technically invisible brick maps, then we're back up to 164 frames per second. This would be, this terrain you would be seeing would be repeated across all the chunks, so technically we're not even going to see the brick maps down here. Like that, but let me turn it back to regular. So this terrain would just be repeated across all the chunks, so, you know, of course, if we're not doing level of distance or anything like that, we would quickly destroy the frame rate again. But we're back down to like 3,000 draw calls, which is pretty good. One day of work and we're back up to 164 frames per second. Of course, on a 3080, of course a 3080 is going to be able to do that, but now we need to start targeting lower end hardware. But this is pretty insane. We're already back up to a full stable frame rate, rendering 32 by 64 by 64 voxels on the top layer, probably more. 3,000 draw calls, 3,000 brick maps. Not bad, not bad at all. So that's what I've been working on. I did it by I just introduced another function. If I go into voxel helpers, and we go into, I think it's create mesh. Create mesh? No create mesh. Where is it? Where is that function? Generate mesh. It's called generate mesh. I can never remember all the names that I said, but we just do a really quick check. Like, first we populate the voxel with noise, and we'll know that the voxel, we populate the brick maps with noise, and we'll know that the brick maps are completely filled if, you know, the brick maps are, they're working on a substation up the road. So right there I lost power. Somehow the video didn't get entirely deleted. It was actually salvaged up until I lost power, which is pretty crazy. But we can get back to where I was explaining things. So I determine if a brick map is completely filled with voxels, and if it's in that case, then I just go into this and I determine if any of those voxels are visible from another brick map, and then I create a whole quad right there that just stretches across the entire brick map, which is what you saw on the edge brick maps there. So a day of work, and I'm already back up to 164 frames per second. For just one chunk, 256 by 256 voxels. One chunk, no LOD, so there's still plenty of more optimizations I can make, but it's already pretty insane just to get back to where I was. So I'm pretty happy with the results. Thank you. Thank you, thank you. See you later. Hello, ladies and gentlemen. I was rather lazy today, but I still got some work done. It was mostly in consolidating all the different logic and how I measured out the brick maps and the brick grids and the voxels, the brick grid resolution. So I have chunks, and the chunks are just some arbitrary unit, like 64 by 64 by 64 units across. Can I open up my chunk window, please? Please? Okay, there we go. So the chunks are 64 by 64 by 64, and I can specify like arbitrary brick map sizes inside. Brick maps are just a way to further sparsely represent my voxels. The chunks contain brick maps, and the brick maps are what actually contain the voxel data. And the brick maps can have arbitrary sizes. What I was showing you previously was the brick grid resolution was 32, where I had, in any given axis, X, Y, or Z, I had 32 brick maps across. But I adjusted the size, so now I only have 8 brick maps across. I'm sorry, the terminology is very confusing. I only have 8 brick maps across now in any given direction. But if I scroll up, you might be able to see the text. Yeah, so I was generating it earlier. So 8 by 8 by 8 means 512 brick maps. And it only takes 3 seconds to generate, to populate the voxels, and then to mesh them all together. Why is it so difficult? And Can I close out all my I'm GUI windows? Yes, okay. And so with all the I'm GUI windows closed, we're still at 164 frames per second. And I can show you the triangle data up here. We're only rendering 262,000 triangles. It's less than before, the 315,000 from the previous days. And you see that the brick maps are larger, meaning larger triangles. We're still not totally greedy meshing the actual voxel data, but all the fully populated ones, I had special functions for that just, create whole triangles across the whole face. And as you can see, we are at 262 draw calls, which is at least in like one order of magnitude below what we were at yesterday. And I can toggle it further so we're not drawing all the technically invisible ones. And we're down to 189 draw calls. So it's much, much better than yesterday. So just experimenting with different parameters for the code. I think that the fewer brick maps I use in a chunk, the better my performance is, surprisingly. So I can probably move forward having 8x8x8 brick maps in every chunk, and those brick maps will have 64x64x64 voxels, which I could probably pack into 64-bit integers for intrinsics on the CPU. So more stuff to experiment with. The noise generation looks fucked up because I never really adjusted it for the larger brick maps, but that doesn't really matter. It still populates them, so that's all I really care about. So not really much work done today, but just profiling different things, testing out different things, and I'm pleased with the results. So that's it for today. Thank you. Hello, ladies and gentlemen. It has been a long day. I have totally lost track of anything I was going to talk about. I just had a horrible debugging session because I had no idea what I was doing, but the whole idea was that I wanted to draw a ray from the center of the camera to wherever the mouse is pointing. And because I have camera-based rendering, where the camera is technically the origin of the world scene that I'm rendering, I was having extreme difficulty because just setting it to 0, 0, 0 wasn't enough. And then I eventually realized that wherever the camera was facing, it could be like negative Z, positive Z, like any 3D direction in space. I just wanted to have the normal of that camera. I just wanted to have the point in space that would always be in front of that camera. And then from there, I would cast a line from wherever the mouse is pointing. And I finally figured it out by just creating a function called, if I can even remember where I put it, I can't even remember. Get point in front of the camera. And that's essentially what I did. And it finally works, and I can toggle it on and off. But the whole reason that I wanted to do any of this, can I please see my IMGUI windows? I hate how they vanish all the time. The whole reason for doing this, if you remember yesterday, I was able to toggle the size of the brick maps. I reduced the brick map size down to 4x4x4, so I have 64 brick maps, which brings the draw calls down to 36, which, reduces the draw calls by 2 orders of magnitude from where it was yesterday. And so then I also added a little ray casting function. Can we see that line anymore? We can't. I guess it's obscured by the voxels, so my line rendering needs to be adjusted for that. But as you can see, now we can pick individual voxels in the scene. And you can see over here, the selected voxel adjusts to the index as well as the brick map. We can highlight the voxel and the brick map that it's in, but the lines are still obscured by the voxel rendering, it's just how I figure out the depths when I render with BGFX, so it's not really a problem. But you can see how the structures around the voxels light up depending on where the mouse is pointing, and that's part of it. So we can pick the brick map and we can pick the voxel, which is just another step to getting us towards editing the voxels. But the real reason that I had this is that I wanted to be able to point into a brick map and be able to see the information. So if you look over here, you'll see that when I'm not mousing over a voxel, there's no information. But when I do, you see the selected chunk, the selected brick map index, the selected voxel index, the amount of voxels in that brick map, and the voxel resolution of that brick map. And so I wanted to do this because there is a binary greedy meshing repository that I have no idea how it's working, but for some reason they use 62 cubed voxel sizes for their chunks. And this was just the first step to getting there. But I felt like I wanted more debugging information, which is why today I got ray casting working, so now we can select the different voxels. You can see it lighting up. You can see the brick map lights up. And we can also cast array from the mouse. But because it's a line and I have the depth testing set up in a certain way in BGFX, it's obscured by the voxels, but that's not really an issue. So, I mean, I guess I'm pleased with the work today. It was really brutal finally figuring out this line ray casting thing, but hey, it's finally working, thank God. Thank you for watching. That's pretty much all I did today, and I'm going to go to bed right now. Good night. Hello, ladies and gentlemen. I spent the day making a few optimizations. If I full screen it and close down all the IMGUI windows. Yeah, sure, that's good enough. So I got the mouse ray cursor drawing thing working how I wanted it. Before it was drawing from the center of the screen, but as I decided to move the point behind the camera so it kind of looks like a little lance coming out from behind you that aims wherever your mouse goes, which is pretty cool. I like that a little bit better, but that's not really what we're here to talk about. What we're here to talk about is my incredibly fast noise generation. We're going to click it, and within half a second, we have a fully populated chunk. About 64 brick maps total. And now you can see the actual brick map subdividers over the chunk, and now they highlight whenever we mouse into them. I think that's pretty much it. I got the noise generation this fast. It was taking 3 seconds before, but I realized that I had an unordered set inside every brick map. I have 64 brick maps in every chunk. And what I was doing every operation was whenever I populated or removed a voxel, I was inserting that voxel index into the unordered set, which allocated memory, churned the heap a little bit, and I realized I wasn't even using it for any operations at the moment. Maybe I'll need it in the future, but I can't really foresee any circumstances where I will need it. And that cut my, like, it took 3 seconds to generate, and now it takes like half a second, so I mean, I can't do basic math right now. It like reduced the creation time of a single chunk by 6 times, which is pretty insane. We'll do it again just to demonstrate. Look at that. That's insane. It's huge. So the next steps, I pretty much got everything working that I wanted to. All my systems are working pretty well now. So what I want to do at this point is, I mean, I was writing it all out. I was brainstorming it, but I got the faster noise generation. That's what I was working on today. I would want to introduce different voxel types, because right now I'm just setting everything to like a static value, like 255. The value doesn't matter. It just populates a chunk, populates a voxel. And then I would want to reduce the vertex size that I'm pushing to the GPU. And then I think I would use binary greedy meshing just to make the meshing a little bit faster. But really, if you look at the timer here, it takes 3 seconds to generate the noise. And it only takes like, it takes 0.3 seconds to generate the noise, and it only takes 0.2 seconds to generate the mesh for this whole chunk. So the noise generation is still the most taxing thing. I can generate meshes pretty rapidly, but I can imagine that when I have different voxel types, it'll make generating the mesh a bit slower, which is why I need to start looking into binary operations. You can see that looks pretty cool, actually. Let me slow down the camera so you can, wow, that's cool. Yeah, but that's what it looks like right now, my greedy meshing. This is insane. I've never seen it like this. I'm very happy to see this all coming together. But this is just the beginning. I got pretty far today, and then I sat down and was brainstorming the massive steps that I need to do next. I need to get this thing multi-threaded. I need to add LODs. I need to get binary greedy meshing working, but we're slowly coming together, and we can soon make a voxel game out of this, so I'm pretty excited. The noise generation looks a lot better already too, so I'm pretty happy with the progress. Just got to work on it a little bit every day, and you would be surprised how far you can get. That is all for this one. Oh yeah, and also the memory consumption goes down by like 3 times. I was using like 600 megabytes before, but now it's only 200 megabytes for a whole chunk, and Of course, I would recycle that memory for every chunk when I multi-thread it, but we're getting ahead of ourselves. That's all to come in the next weeks and months. That's all for now. Thank you. Hello, ladies and gentlemen. It is 7 p.m., September 10th, 2024. Today I didn't really get much work done. I was driving down to Maryland and back. Where are my windows? I hate wrangling all of these windows. Okay. Oh dear. Oh dear. Please. Okay, that's good. Okay, so I made my chunk generation just a little bit faster. I now create an array of all the voxel data and then I mem copy it into the actual array that I buffer. And then I also added random colors to it. And layers. You see these layers. I need to update them for the buffers to go through. They have all these little holes because I can remove voxels from them now, but because I'm not double buffering it, what I'm doing is that every time I create a greedy mesh, you see that the mesh is just, oh my god, I didn't see this yet. That is fucked up. I guess some problem with my greedy meshing, something to experiment with. Some problem with my voxel editing and how I mesh them all together, but of course there's going to be issues with that. I definitely haven't optimized that. But what happens is that I just have a single buffer of all the vertices that I want to push to the GPU. So if I'm rapidly editing it like multiple frames, it's not really... Is it because OBS is recording? Okay, so you see a little bit of flickering. That's strange. It's not flickering as much as it used to. I guess the performance characteristics vary between boot ups. But usually it'll flicker because I'm not double buffering it, because every time I remesh it, because I need to remesh it every time I remove voxels from it, like you see here. Let me get a little bit closer, just so you can actually understand what's going on. So we see the voxel geometry, and I'm just holding right click, and now you can see me destroying it, and I'm like kind of tearing apart this wall. But yeah, so you see flickering there. That's because I'm storing all the vertex data in a single buffer, and then immediately on the next frame, I'm deleting that entire vertex buffer and recreating it for the greedy mesh. But BGFX hasn't fully caught up and hasn't fully processed that entire buffer, so it gets confused when I completely erase the whole thing and refill it. So I think that's where double buffering comes in. I never really understood the concept before, but I think just, you know, the mother of invention is necessity, something like that. So out of necessity, I finally need to learn what double buffering is. So that is the current issue that I'm facing. But as you can see, we have voxel editing. We have multiple colors. We can regenerate all the voxels, and we can also, when we do that, I just hooked it up so that it also selects new random colors. I can regenerate it again just to show you. Let's just keep going until we get a nice looking color. Nice looking color palette. I don't know. That looks cool. But anyway, you see over here, for the different layers, I also even print out all the different colors for all the different faces, because each of these cubes, a cube has 6 faces, and so any given face, you see that the color will change. Like right now we're facing the Z negative face, and so we are at layer 1, so you can see Z negative is this kind of pinkish color. No, sorry, that's Z negative. Z negative is that sandy color. So we can go to the other side. I just boosted up the camera speed, and you'll see that we're in the Z positive direction now. And you see it's kind of like lime color. So pretty interesting stuff. What was I trying to do? Let's get some more colors. Let's get some more colors going. Yeah, so that's pretty much all we can do. We can just get random colors. We can delete voxels now, you know, just getting a little bit closer to what we actually want to do with the engine, but we need to scale it up because right now we're only drawing one chunk and we want to be able to draw chunks in every single direction. So that means that we need to reduce the vertex data memory footprint that we're sending to the GPU, multi-thread it, and get it to span across multiple chunks. So that's going to be coming in the next few weeks. It's going to take a while because at first we need to figure out double buffering and compressing all the vertex data, and then getting a faster meshing algorithm. But I mean, as far as meshing goes, I can show you the timers right here, and it's been accumulating I can just restart it. The timers accumulate every time I remesh it. Here, let me click this, and then you'll see that the total time to voxelize and mesh is like half a second. Voxelizing takes like 0.03? No, sorry. Voxelizing it takes 0.35 seconds, and then meshing it takes like 0.17 seconds. So meshing it, I remesh it every time. You can see the flickering now. Like I remesh it every time I update a single voxel because you need to, you know, if some part of the topography of the mesh changes, then you need to remesh it. So the meshing really doesn't take that long, but I need to double buffer it to stop the flickering. So that's what I will be working on next. Thank you, thank you. That is all for today. And you can see I even reduced the memory footprint a little bit more. So more progress. See ya. One more thing I forgot to mention, but this is rather important. I spent like 3 or 4 hours a day getting this set up. You can see I finally have my squat rack set up. So I'll wake up and I'll just start cranking out mad reps and then get to work. So that's the current goal. The hyperbolic time chamber is now complete. Now we just gotta grind for the next 50 years until I fucking die, and nobody cares. Nobody fucking... Hello, ladies and gentlemen. I wasn't originally going to make a devlog today, but I figured I might as well. Might as well try and update every day. You see this little quad here because I'm just trying to test out new features in the shader, but I haven't gotten around to it. What I have been doing is I've been messing more with the voxels and how I buffer it to the GPU. So you can see that previously we had the flickering. If I zoom in, you can see the flickering happening. I wonder if it happens on the other side. Probably, yeah, still just a little bit, yeah. But I guess it happens everywhere. But the reason that it's happening is because on like frame X, I have the brick map fully populated, and so that's going to the GPU. All the data is being transferred from the CPU to the GPU. And on frame X plus 1, I completely erase that entire buffer that the GPU is trying to copy to, and I remesh it and update it and repopulate it, which is why you saw that such bad flickering. And you still see a little bit of bad flickering because I still, you know, mess with the buffer as it's being populated, like immediately the next frame. And so now if I toggle my double buffering, you can see that there is no more flickering. I'm editing the voxel data, and there is no more flickering happening that you can perceive. And that's because now I have a back buffer and a front buffer. And the front buffer is what you see rendering, and the back buffer on any given frame, if I edit the mesh, I'll populate the back buffer, and then every frame I swap the two. So now you see the freshly updated buffer. And I just keep cycling through them every frame. So the flickering is much diminished. But like if I pull the IMGUI window off the screen, then you can probably see some flickering. Like if I move them both off the screen, because usually having the IMGUI windows detached, it still causes sufficient lag. But I'm still not seeing any flickering, so that's nice. But it's still very expensive to update. If I pull up the debug stats, and over here you can see the submit wait time, and I'm, you know, editing, I'm remeshing this, and so you can see that the GPU is waiting to receive the data from the CPU, and it's only single-threaded, so I can see that why in like a really tiny voxel game engine like this, it's not really that tiny, but you would need to multi-thread it just to distribute the workload across multiple threads, because we only have a budget. Like we're running at 164. This monitor can handle 164 frames per second, which means that we only have a budget of like 6 milliseconds, and you can see that updating to the GPU double buffered from the CPU on like really a high-end hardware like this takes 15 milliseconds, and we're not running with the best algorithms, but you know the way one of the ways around that, if you're not very good at programming, is just to multi-thread it. But multi-threading has its own difficulties, as I've already experienced when I was trying to get ray tracing working in the past. And I can also see why ray tracing is a very nice thing to have, because oh dear, what did I do? Oh yes, okay, this is a known issue. This is because I try to populate another brick grid that is larger. Like I'm only working with one chunk here. I haven't stretched the whole system to multiple chunks yet, so it'll crash if I try to update another brick map. But that is what I'll be dealing with in the future when I try to scale this up to multiple chunks. As you can see, it's not quite brittle. I know exactly what will break it, so I just need to keep that in mind. So now we're double buffering again. So I can see why you would need to ray trace instead because I can't remember what button it was. Oh yeah, it was this. Okay, so like we need to remesh it all every single frame and draw all these triangles like 164 frames per second. And you can see that we are drawing 158,000 triangles 164 times a second. So that'll get pretty expensive. So if we can cast like 2 million rays into the scene and get some efficient way to organize all the voxels, kind of like you see with the brick maps, which subdivide into the voxels, then you can kind of get ray tracing working on decent hardware. So there's a lot of different things you can do, but if you're managing voxels at this level, then it will get expensive and you will need to optimize. And that's the never-ending learning curve that I'm running into. I just need to keep learning these new techniques to optimize. But right now I'm not even texturing. The next thing I want to do is check texture, get ambient occlusion, and then there's an even better algorithm for greedy meshing called binary greedy meshing, where you somehow, like I just got the basics of that, where I have 62 voxels in every given direction in a brick map. 62 because we want to pad each direction with 2 extra bits on either side, 2 extra voxels from the neighboring brick map so that we can run a binary operation with a 64-bit integer. But that is very complex and I still don't fully understand it, so that's what I'll be working on in the coming days. So I really only got double buffering working today, and then I started reading a lot more documentation, and there's trade-offs you make every day. You can only get a certain amount of work done, but I'm working on it. It's slowly coming together every day. We at least got rid of the flickering. It doesn't need to be perfect, it just needs to work. And then once I get all the basic systems up and running, then I can optimize. So again, that's what I'll be doing for the next few months. But that is all for today. This is how the code works. So I have the buffer, I have the updating buffer. I have like the updating buffer and then the rendering buffer, and on any given frame I'm updating the updating buffer with any updates that need to go to the updating buffer. So makes a lot of sense, doesn't it? I copied out that mem set because like you have frame T, and then on T+1 I was fleshing out the whole array, which made the flickering even worse. So I got rid of that, and then I just keep track of how far into the buffers I need to populate the data, and then I just flush out the rest with zeros because it's being unused. That's what was causing those invisible faces. In my previous devlogs, like if you go inside the mesh and you saw those invisible faces, it was because I had extra vertex data that I never flushed out whenever I remeshed the buffer. So doesn't make much sense, but you need to go and see the other previous things. So we're like 2,000 lines of code, 2168 lines of code, so just for the voxel stuff. Well, if we include the, where am I? The voxel helpers, that's like what, 300 lines of code, and then plug-in is the actual thing. It's like another 800 lines. So we're like probably 4,000 lines of code for this whole plugin, this voxel plugin that I load as a hot swap DLL to my engine. So lots of code, and it's only going to keep piling on. So that's all for today. Really not that much. Thank you. Hello, ladies and gentlemen. It is 8:16 p.m., September 12th, 2024. Where do I even begin? Today I worked on getting textures to the GPU. Texturing, we're talking about texturing, where you take an image like a PNG or a JPG and then you paste it over geometry. So we have our little scene here, and we have this little quad. And we can, oh look, we just put a little Minecraft texture on it. That's all the work that I did today. Now, I'll actually show you. So as you can see, it almost kind of looks like Minecraft now. You can see that we have all these little grass blocks all over the place, and we can keep digging, but they're only ever grass. I can cycle the texture, so now it's all stone. And I can even apply colors to it, the random colors that we generated. So now you can see that it's still the stone texture, but we also multiply it by that same color. And you can see that we have these very large textures over here, but we can edit them, and now we'll have all the smaller little voxels in them. And I need to enable double buffering so that we stop flickering like that. So we have texturing now, finally. Now the next step would be to have lighting. This looks like very early Minecraft, like alpha Minecraft, before he had ambient occlusion or actual smooth lighting. So that's what I've been doing today. And if I cycle through them a bit more, we can... Look, we even have snow! Wow, it's crazy! It's like a little snow biome for Minecraft. But the way I'm doing this is that if the normal the normal in the Y plus direction. If you know the positive Y facing face of the block, I just color that whole thing white. That is all that progress. And I was also experimenting with other shaders today, and oh yeah, look, I love seeing these really big grass blocks. Let me just ruin it for you. So another cool thing that you can do with shaders is that you can warp the vertices. If I do this, you can see it slowly get more and more warped out of place. You can kind of like twist it around. So I'm just like multiplying, swizzling the vertices of the textures, and it looks quite fucked up. So a bunch of cool stuff you can do with little shaders. But I think the next step is really just getting a more efficient binary greedy meshing algorithm, because you see I still have the lag when I update the faces. But everything in good time. I mean, if it's really a big problem, I can just multi-thread the updates, but I would like to have a bit more robust system going. So the way that I upload textures is I'm using the BGFX library. I was originally using OpenGL like a year ago, but I just figured very naively, like, oh, OpenGL 4.6 can only target like Windows and Linux. What if I want to target Mac? What if I want to target PS4 or Nintendo Switch? So BGFX is a library that can target any system. It abstracts every single rendering platform on any given system up to another lower level language that you can use. But the documentation for it is very poor, and it has some other libraries attached to it like BX or BIMG. And so I was trying to use image parse from the BIMG library, and you see it's just this single little file, and I was getting a linker error trying to use this one function. And then I spent 3 hours until I realized that I needed to also attach the BIMG decode debug.lib, because the BIMG debug.lib wasn't enough. I figured this out by trolling through the Discord, and then I saw older messages, and the guy that made BGFX was shitting on CMake. He's like, oh, CMake is garbage, but you know, I mean, I can understand any complaints you can have towards CMake because it's poorly documented. But if your whole rendering engine is also poorly documented, then he's basically a hypocrite. So it was infuriating wasting 3 hours, but that's just the part of learning different libraries like this. I'm sure if anyone wants to pick up my library, there'd be a lot of stuff they need to trial and error to get it working. So 3 hours just to get textures working, but once I had that, I just where are my actual shaders? So I have the fragment shader here, I have the vertex shader here. I just push the textures over to the fragment shader. And then the fragment shader I load. Like, you could use a texture atlas. Like, Minecraft uses a texture atlas where it's just a big square of all the different textures you need. But I'm doing it very shittily, very naively right now, where I just send the entire, like, .png files over. Just one for the... I can, in fact, show you my grass.png, my grass top PNG, my stone PNG. I don't send over the texture atlas or anything. I'm just doing it very slowly, but... just to test it out, and it's working so far. So I got textures today. I got I can't even remember what I got working yesterday, honestly. But tomorrow I'm gonna start working on binary greedy meshing, just to have a faster meshing algorithm. And then from there I can attach ambient occlusion to that, and then I think I'll experiment with ray tracing just to figure out what the most efficient is for the smallest voxels I can possibly have. And then from there, I need to scale it up to multiple chunks and get multi-threading working. So there's still much left to be done, but the progress being made is... I'm quite happy with the progress being made, honestly. Let's just give it another look-see. I do love all these pretty little cubes, all these little grass blocks. It's literally Minecraft. It's crazy. I mean, there's no diamonds or anything yet. It's double buffered Minecraft. I'm sure Minecraft is like triple buffered. Minecraft also uses BGFX, by the way. So it's definitely a good enough rendering for a lot of different needs. So if it's good enough for Minecraft, it's good enough for John Blow, it's good enough for me. Whoa. Whoa. Yeah, okay. Thank you for watching, ladies and gentlemen. Have a good day. Hello, ladies and gentlemen. Today I spent 8 hours looking at this amazing binary greedy meshing repo that uses binary operations to greedy mesh all the voxels together, and it takes like maybe 200 microseconds at most for a 62 cubed voxel populated chunk. And so I looked in the code, and I saw in the mesher there's like 3 main steps. First, they break down the entire chunk into a bunch of columns of ones and zeros. Columns of like every single axis that you can view the chunk from. And then you create a face mask of that, and then you binary mesh it all together. But because I'm a total novice when it comes to this stuff, I needed to take it step by step, which means just looking at this one line, which calls generate initial axis columns. And so I copied it over into my own code, and I needed to rearrange the axes. It originally did like ZYX. Is this the right one? Yeah, generate initial axis columns. And so it originally went XYZ. My data packing is the other way, where I generate voxels first, like 0 to 63x, and then I increment the y, which takes it to index 64, and then I go another, and so I do it like ZYX order voxels. And so I needed to reorder the equation, the algorithm, and then I just by hand I worked it out in Obsidian. And also this journal right here, I drew like a little representation of like, so you have this is the inner chunk, like pretending it's 2 by 2, and then you add padding on either side, so you get like a 4 by 4 by 4 little chunk. And then I just pretend that uint 4 variables exist, like 4-bit numbers exist. And then I went line by line, like in the inner loop, where you go through all the z's and then the y's and then the x's in the inner loop, and then you calculate each position of the axis columns, because it generates these columns. Like you have this, imagine that you're looking at this big cube. It's the big volume of all the little voxels, and so you can look at it from different perspectives. Like from my view right now, let's say that we're looking at the z positive face of the chunk, and so this is the first column, the 0th column. This is the first column, second, third, fourth, like 0th column, 64th column. So you can kind of increment it like you do voxels, and you can generate whole columns of 64-bit integers representing all the voxels in that one direction. And I had no idea that it could work like this. This is an incredibly powerful way that you can represent entire chunks of voxels with just binary operations to get incredibly fast algorithms working. And this is the first step towards it. I spent 8 hours just understanding the first step of this operation. There's like 3 more to go. But if I grind out the next 3 days, maybe I'll be able to understand the binary greeting meshing algorithm. But the final step that I took today, once I worked out, like, here is a basic representation of it. I should probably zoom in on it. Can I zoom in on it? Okay, so like imagine that you're looking at the z positive face. This is the index of the columns that you're looking in. Then like this is like the very back row. This is the very back row. The another row in front of that. Another row in front of that. This is the most front row of this 4 by 4 by 4 chunk. And so you're looking in the z positive face direction, the 0th index, and of course. This is 0, this is 0, this is 0. Oops, I added another column to that. This is 0. So there's nothing here. This is just 0, 0, 0, 0. But you look in at like the 1, 2, 3, the third column from the right. And so you start looking back at it. The least significant bit means that that's the furthest one away. So this is the closest one. So that's a 0. This is a 0. This is a 1. This is populated, and this is a 0. So the binary that you get for that is 0, 0, 1, 0, or a 2. But the 2 doesn't matter. What matters is the way that you pack the binary data. And so this little equation does it for you. But apparently in the greedy meshing library, you can pre-generate it. You can pre-generate all that data. So I don't know how to do that yet. I guess I'll figure that out because I'm looking at the earliest entry in that repo. But I'll learn that next. But so just to test all this newfound knowledge out, I just made a brick map with padding on either side, like 62 cubed, 64 padding, where you have padding in each axis, and then I just randomly added different voxels to it, different voxel indices. And then I made a little loop that printed out, like, so first I ran through this, oh dear. I'm losing track of all my different windows. So first let me zoom in because the compression is so horrible. So I generate all the columns, you know. So I put like 3 voxels into this big cube in random places, and then I generate the columns that like I'm pretty much like taking this big chunk and looking at it through every direction, and I'm generating columns of like all the voxels that I see looking down the cube in each direction. And then I just loop through all those columns and I print out like the different values from the different angles that you can observe the chunk from. So like the 0th index that I populate, like if we're looking at the chunk this direction, almost fell over. If we're looking at the chunk from this direction, the very back left bottom index is the 0th index in the chunk. And so I populated that. And so if you look at that through the positive z-axis, then you look at the whole column, and it's going to be zeros all the way until the least significant bit, which you can see right here. So I did it step by step, and I laid out, I wrote down all this shit, and I worked it out in Obsidian right here. And, you know, just went step by step and like even wrote down my own reasoning, and it finally all makes sense. 8 hours, and I can finally understand the first step to the binary meshing algorithm, which is you just got to put in the time if you really want to become a wizard like this, and that's what I'm trying to do. So I'm slowly getting there. It just takes a very long time, but I'm slowly getting there, and maybe in the next few days I'll actually have a faster binary greedy meshing algorithm that I can show you. But for now, that is all I did, and I'll just have to leave it there, and maybe tomorrow I'll be able to explain a bit more and show you a bit more, but I've just been writing stuff out and printing stuff to the monitor, so nothing visual yet, but this is just the first step. And I'm happy to have made this because you see other people try to explain like, oh, I made a binary greedy meshing algorithm, then they show you the code, and maybe I'm just stupid, but I actually need to visualize the whole thing and work it out line by line to actually understand it. So if anyone else needs to understand it, maybe this will be a useful video. So if you want to understand any algorithm, you just need to open up Obsidian, copy over the code, reduce it to the simplest format, like just pretend that there's like 2-bit or 4-bit integers in a computer, and then you just work from there. So that's what you do if you really want to deeply understand anything. So more will come tomorrow. I'm just going to work harder at this, and hopefully I'll actually get somewhere. But that is all I did today, so thank you, and I'll talk to you later. Hello, ladies and gentlemen. It is September 14th, 2024, 9:32 p.m. I've gone through another long haul today figuring out the binary greedy meshing algorithm. I pulled apart more of the loops, and then eventually I saw that I needed to pack my vertices into just 32 bits for position XYZ. Where's my code? For my XYZ, my ambient occlusion, which is included in the binary meshing, but I haven't got it incorporated yet. I incorporated a lot of the code. So you can see that it's just a single float that I pack all the data into. And I can actually show you right now. So what you see right here are just 2 voxels in the binary greedy mesh brick map. The brick map itself is invisible. I haven't set up all the code to draw the block around it. This is all just to test it. But you can see that I can add more voxels to it. And it grows, but only in the positive z direction, and the back face is missing, so it's not perfect yet. But as you can see, I mean, I can keep adding more rows to it, but it grows in the positive z direction. The way that my brick maps grow, I can show you the voxelized data. They grow in the positive x direction, and then they stack another y on top. X, Y, X, Y, X, Y, X, Y, and then they come over 1 in the z-axis and grow more X, Y, X, Y. So I think that's like X, Y, Z ordering, and the way that the binary greedy meshing code works is like Z, Y, X ordering. So it's totally backwards, but at least I have the code working. The code, it doesn't crash me, and you can see that there are voxels that get added, but I just need to figure out why the very front and back faces are cold. Yeah, you can see that it vanished right there. So I'm still figuring it out. There's still a lot of problems to work out. Why? What is that? Yeah, plenty of problems to work out with it. It's not perfect yet, but it's just the start. It is strange. So I just gotta write more code to debug it, more testing framework around it, and then try and, like, I think the plan is that I'll just, here I have it in this new binary mesher script. And the binary meshing code is like right here. So the plan is I'll just add printfs for every single step, and I'll just print out to the console literally every single thing that the code is doing so that I can finally understand it, but it'll probably take a few more days to do that. But once I do that, I'll have ambient occlusion, which means that I'll have relatively smooth lighting for my voxels, so it'll put me forward by a lot. And I profiled my regular greedy meshing code, and even in the best case, it takes 10 milliseconds, and with a budget of 164 frames per second, I only have 6 milliseconds per frame to do any given calculation. So if you want to, where is the code? I keep missing it. I keep losing my place. So I think yeah, so here we go, and you can see down here, like, I'll remove a voxel and I'll remesh it. So down here you can see that the remeshing takes, like, at best 0.01 seconds, which means 10 milliseconds. So it's definitely not good enough. So there will be a frame drop even if you remove one voxel, because the whole mesh will need to regenerate. So binary greedy meshing would be very nice to have, and it would power up my engine with ambient occlusion and generate, I can't remember what the structure is called, an opaque mask. It'll generate an opaque mask for me, which will make physics calculations better when I get to that in the future. So this is a decent usage of my time. It's just going to take a while to actually get it working, but once I do, it'll make the engine much more powerful. So, but as it stands, I keep losing all these windows. As it stands, I can get a really shitty version of binary meshing working, but there's still a lot of work to be done. So that's where I'm leaving off today. I was like figuring out how the code worked for 8 hours before I figured that I would just work on getting vertex packing, where I just take in an A position, which is a vector, but I just read the X component, which is a 32-bit integer, and then I unpack the X, Y, Z, and then I send those to the fragment shader, and then I just color them white. So that took took a while to debug, because I've never done vertex packing before, where you usually the X, Y, Z integers, they would each be 32 bits at least, but you can pack them all. You can pack them each into 6 bits, and so then you can package all of that into 32 bits and then send it to the GPU to save a lot of space and a lot of performance power. But then you need to unpack it, and I've never done that before, and I've never done that in BGFX, which is the rendering, the shader framework that I'm working with. So there's a lot to learn, a lot of trial and error, and there's got to be even more tomorrow and the day after and the day after and the day after and weeks and months from now. But eventually I'll get it, and it just takes a long time to actually understand it all. So kind of demoralizing, but that's just the price you pay when you want to grow. So that's what I've been doing, and that's what I will continue to be doing. And maybe, hopefully, in a few weeks or months from now, it'll actually make sense and my engine will be much fancier. But as it stands, there's a lot of work to be done. So that's all for now. Thank you. See ya. Hello, ladies and gentlemen. It is September 15th, 2024, 7:17 p.m. It is day 3 of reverse engineering the binary greedy meshing algorithm. I went through again and I deconstructed so many of the loops, and I cluttered up all the code with printf statements, and I printed out tons of binary and read through it line by line. And I even made these big tables of generating the ambient occlusion and which directions we look in for every single face. And I was like just pointing myself in different directions, mumbling X, Y, Z, X, Y, X, Y, up, down, left, right. We go out of phase 0 and turn left. All this different shit to wrap my head around it. And eventually, I realized, well, I mean, I already knew this, but the way that they organize the voxels, you can organize the voxels in separate ways. They were doing it in Y, X, Z ordering, where the most rapidly increasing voxels are the Z axis, 0, 1, 2, 3, 4, 5, 6. And then as soon as you hit 63, you increment on the X axis, and then you go another 64 forward on the Z axis until you go like 64 times 64, and then you increment on the Y-axis. So that's how they incremented their voxels. But the way I do it is I do it ZYX, where X increments most rapidly. Where X goes 0 through 64, I increment the Y, so 64 to 127, and then as soon as I hit 64 times 64, I increment the Z. So I just pack my voxels differently than they do. And so I was trying to figure out I was reverse engineering the algorithm to discern exactly how they order their axes and faces, until eventually I realized that I could just swap, so you see this horrifically cluttered up code. Let me zoom in for you. Oh dear, that is a bit too much. The resolution on this video I know is going to be horrible because Discord is cheap. So I'll go down to where we generate the faces, all these different faces. Originally, you generated the Y plus face first, then the Y negative face, and then the X positive face, and the X negative face, the Z positive face, and then the Z negative face. But I just swapped all those faces around because I made like a little chart in Obsidian. I think this is it. Yeah, so you can see like all the way up here, and then I spent all day just filling it out. And then eventually I realized that I just needed to swap the face generation code around, where I copied this code inside the if statements, and then I just swapped it around, and it works. It works after spending days on this. So I'm just going to generate an entire XY plane at a time. XY, yeah, a whole XY plane at a time. Oh dear, what did I added breakpoints. Yeah, okay. I was just debugging it right now. Okay, so you can see that I'm adding a whole slice, a whole XY slice at a time to the brick map, and I can press it like 62, 63 times until it stops incrementing. And that is a fully populated brick map with a binary greedy meshing algorithm correctly implemented in my engine. Of course, there's no colors or textures or ambient occlusion yet. I literally just got it working after realizing my folly. And I'm quite excited now that I actually have the first step for binary greedy meshing. If I can really get this to work, then it can cut back on meshing time, and I can actually move my voxel forward so I can get really high consistent frame rates, even with really intensive voxel editing. So I am quite pleased with myself. It works. I can clear it all away and redo it. You can see a little bit of lag, but I'm printing out a lot of binary code every time I press V to generate a whole slice, and I'm also doing a bunch of checks to see if the voxel is in the padding or not. So there's a lot of stuff that I added in the code that'll slow it down, but once I clean it all up, it should be much, much faster than my regular greedy meshing algorithm. So it's finally working, and it took 3 days to realize that I was an idiot, but that's usually how I make progress. I spend a long time, and then finally something clicks, and then I'm like, oh wait, I can just reorganize the code, or I can look at it this way, and then it'll finally work. And look at that, we don't have any memory leaks. We have no memory leaks, and it only takes 17 megabytes to mesh it, so that is pretty insane. I mean, it's of course a brick map, so I think if we do like 32 of those, it wasn't like the chunks. Our chunks, when we generated all that, it was like 120 megabytes, so if we do like 17 times 32, that'll be much more than 100 megabytes, but I'm being very inefficient with memory. I'm using vectors instead of arrays. I'm not really caring about efficiency right now. I'm just caring about getting the code to work. But now that it works, I can clean it all up, and it'll be much, much faster. So I'm very excited, and that is how I track the time that I spend on these things, and that's 7.5 hours of working on it today. So yeah. It's finally working, and now I can step forward and start replacing my other meshing code with a binary meshing algorithm. So that is what I've been doing today. Hopefully tomorrow there will be colors or something new, or just cleaner code. It's my birthday tomorrow, so I'm going to spend time with family, so I won't have much time to dedicate to this. But over the coming weeks, I'll have a much better meshing algorithm. So I'm quite pleased with myself, and that is all for today. Thank you. Have a good one. Hello, ladies and gentlemen. It is September 16th, 8:53 p.m. I didn't get that much work done today. I was spending some time with some family, hiking around Patapsco State Park, but I got back and I implemented the full version 1 of the binary greedy meshing algorithm. And you can populate a brick map with noise. Like you see, this brick map mimics the exact same terrain that we're getting down here. This is brick map 21 right over here, and you can count like Don't know exactly where it begins. It's kind of hard to see, but we count like, oh man, can we really get spot on? Yeah, okay, right here. So 1, 2, 3. Okay, so right there. And then we come over here and you can see the exact same 3 voxels in. I think it's the exact same dimensions of a regular brick map being simulated down there, but we're not scaling it or moving it or anything. We're just trying to get the regular... We're trying to see how the binary greedy mesher works. And so you can see that we have the normal faces. Up is green, left or right is red. I don't know, I have flux on, so it all looks orange to me. But you can even see ambient occlusion. You can see that there's shadows on the voxels, and that comes with the binary greedy meshing repo. Let me just adjust this. I can change the color just to white for you, and we can reload the shader. Oh god, please. Oh god. Okay, well something terrible has happened. Oh, that's because I'm actually an idiot. Okay, so I wasn't actually drawing GL frag. Okay, so you can see that I just color everything white and then you can't see the ambient occlusion. But now I'll multiply the ambient occlusion with that white color and I'll reload the shader. And you can see that we actually have nice, smooth looking lighting, ambient lighting on the voxels. That's very nice. It comes with the binary mesher, so I didn't need to implement it by hand. But it all appears to be working, and we can add back the regular normal colors and the ambient occlusion and reload our shader. And it looks rather nice now. So the next steps... Oh yeah, let me... we will go back to it and just click this a couple times. You can see down here, so the binary meshing, I have a timer for it set up, and so anywhere, any given occasion, it can take anywhere between like 1 millisecond and 2 milliseconds. It's not quite down to the microsecond level that I was hoping for, but that's probably because we're in debug mode. And maybe a few other things, but I mean, even 1 millisecond, I can push that off to another thread, so whenever I need to remesh anything. And this is like the biggest thing that you'll see in my game, so 1 millisecond for a rather large chunk is completely insane. I can't really imagine the player would be editing voxels on such a scale where they would be getting lag at any level. Because especially I would multi-thread it and push that job off to other threads, and they would do it simultaneously as the main thread is calculating other stuff like physics or multiplayer. So it's really not a problem. It's much faster. It's 10 times faster than the greedy meshing algorithm down here. My regular greedy meshing algorithm, not the binary one up here. So the timer's faster, we have ambient occlusion, nice little shadows and nice normal faces, so that puts us ahead quite nicely. And I think the next step is just replacing this whole chunk with the greedy meshed version and then getting voxel editing and seeing how that works. And then scaling it up to all the other chunks, adding level of distance, adding multi-threading, so there's still a lot of work left to be done, but that is where I am now. What each face of this is doing, I can't show you the triangle mesh down here because I just haven't set it up because I'm trying to save data that we're sending to the GPU, but each single quad is 6 vertices, and what I was trying to work on today is vertex pulling, where you just pack whole faces in with a single uint32, but I can't quite get it to work with BGFX, and I'm asking, I've resulted to debasing myself by asking questions on the Discord and getting these really curt responses from these cocksuckers, so hopefully we can learn something useful from them, but usually when you ask something on Discord, you just get shat on by condescending fuckheads. But what do you expect? You're talking to other programmers. So that is what I'm working on. We're a bit further ahead. We got ambient occlusion working. I'm going to integrate the binary meshing with the rest of my engine. And then I'll just move forward and add multi-threading if we really need performance. So I'm really not too stressed out. So that's all for today. Thank you. Have a good one. Hello, ladies and gentlemen. It has been another very long day. It is September 17th, 2024, 9:22 p.m. If you recall, yesterday I was trying to get vertex pulling to work last minute. If I can pull over this little monitor, my little drawing pad, can we please work? Yes, it does work. Okay, so the way that you usually send information to the graphics card is there are these little things called vertices. Triangles are composed of vertices, if you remember basic geometry. And a triangle is composed of 3 vertices. So if we want to draw a quad, a voxel is this little cube thing. And so just from this perspective, you can already see 3 quads. Well, in reality, it has like 6 quads. 1, 2, 3, 4, 5, 6. I can't count a basic triangle. can't count a basic cube. Sorry, it's been a very long day. So a single quad is composed of then 6 vertices. If you want to repeat the vertices, you have 1, 2, 3, and then 4, 5, 6. If you just want to rewrite the vertices, if you're lazy about it. So a quad, a whole voxel is composed of, let's say, 24 vertices if you're repeating all the vertices. So that can add up. That can add up very quickly because a vertex, let's see, a vertex is composed of an x, a y, and a z component. And each of these numbers can be like a uint32, a 32-bit integer, for example. So that is 4 bytes. 1 uint32 is 4 bytes. So 4 times 3 for the x, y, and z components is already 12 bytes we're talking. Just for a single vertex. So if we're sending 24 of these vertices to the GPU, 12 times 24, I can't do basic math. What, like 144 is 12 times 12. What's that times 2 is 288. So that's like 288 vertices that you're sending per voxel. So if I can just undo all this, like even in the best case, you're just talking about one quad. One quad is 6 vertices. 6 times 12 is, what is 6 times 12? That's like half of 144. That is, I can't do basic math right now. It's like 72. Okay, so 72 bytes. That's not good. So the next thing that you can do is vertex pulling, where instead, well, you can like pack the bytes. So you can do vertex packing. I don't know if you can see this too well because the resolution is horrible because I need to send this all to Discord and we're already 2.5 minutes in. So vertex packing is where you can just take all the bits, like what, you can pack like x into 6 bits if you want to compress it into a range of like 0 to 63. So you can take like 6 bits from x, 6 bits from y, 6 bits from z, and fit that all into a single 32-bit integer. And that's what we were doing yesterday. And then, so that's like 6 vertices per quad. So 6 times 4 bytes, because we have 6 vertices and we pack them down into a 32-bit integer, which is 4 bytes. So 6 times 4 is 24 bytes per quad. So that's good. I mean, modern graphics cards have a lot of memory. You can really get away with that nowadays. Can I please do another one? I don't want to save this, please. I strongly no. Please, give me a new one. Don't save. Okay, yeah, that's good. That's good enough. Okay, perfect. Okay, so, apologies, ladies and gentlemen. So, we had 24 bytes when we were trying to get regular vertex packing working, and modern GPUs have a lot of memory to work with, so we probably don't need to push it harder. But I was just curious. I'd like to have that flexibility in my own engine to really push it as far as it can go. And so what you can do next is vertex pulling, where you can pack just the position of the quad, like the x, y, z, the width, and the height of that entire quad into a single 32-bit integer. So we could, like, per quad, feasibly, just use 4 bytes. So, you know, if I want to have color or textures or normals on that, I would need to extend it because packing, like, these 5 things, 5 times 6 is 30. So if we want to put any more information than that, then we need to extend it into another U-bit. uint32t. It's called a uint32t in C++. So we can just have 2 of those, one for the position of the quad and then another for the face that it represents. Like you can have 0 through 5 faces to represent like the x plus, x minus, z plus, z minus, y plus, y minus faces of that voxel. You can have color. So let's just say that I want to use 2 32-bit integers. So we can pack an entire quad into 8 bytes. Which would save us, like, let's just do 8 divided by 24, that is 1/3. We can represent all the information that we want in just 1/3 of the memory that we were using with the already super efficient vertex packing. And so I was trying to get that working today. If I may move this over again. Okay, we don't need the drawing tablet anymore. Fuck the drawing tablet. So I was trying to do that in BGFX, where I was trying to initialize a buffer with just a simple vertex shader, I was trying to create a buffer to send all of this specialized packed quad data into it, but I couldn't get the vertex data buffer working, vertex shader working, and I was asking on BGFX, and I actually got very helpful responses from these people until one of them said you could try BGFX buffer compute type uint. That is the one thing I needed to add as a flag to the vertex buffer that I was creating, and then it finally worked, and I can demonstrate it right here. We have very basic vertex pulling. It doesn't work at all because the shader is backwards. I wrote the shader backwards in BGFX, but as you can see, any one of these quads is only, what, like right now, this quad right here, 8 bytes. This other quad, 8 bytes. So we can really get away with saving a lot of memory and only putting a little bit more performance on vertex shader because it needs to unpack all these things. So unfortunately, my shader logic isn't too correct. I spent the rest of the day on this piece of paper just working out all the logic for the shader, but then I realized, wait, I can just get a bunch of printfs instead in my regular... I can just get a computer to do all this math for me. And so I just copied and pasted the shader logic from this repo, the binary greedy mesher. Version 2 uses vertex pulling, and I was just curious to get it working. So I copied and pasted all that shader code, and now I'm populating quads for it, and I'm test rendering them, and that's what you can see right here. This little thing is like just the first quad that I'm test rendering. So I'm still building up a lot more rendering code. I'm still testing out a lot of things. I spent the entire day figuring out very advanced vertex pulling and shader logic just to see if I can, and I'm already learning a lot, very, very much more about voxels and rendering them. So I don't think that this time was necessarily a waste because I'm learning much more for it and our engine will be much better. I'm not sure if I'll necessarily use vertex pulling permanently in the future, but I would like to have it enabled as a feature. So I think tomorrow I'll get it working, and then I can finally move on with actually getting these this voxel data in the right place that you see down here instead. So, but that's all to come. I have very limited time every day. I spent, like 9 hours just doing constant math on it today. So I'm always working on this. I'm always thinking about it, but I'm only one guy and I can only get so much work done because one of the things that prevents BGFX from getting picked up is how obscure it is and how much issues you run into when you try to implement basic OpenGL shader techniques in it. But you just got to learn through failure, and that's what I'm doing every day, and eventually we'll get there. So this is just one step closer, and tomorrow we'll be a bit further ahead, and eventually we'll have these really nice voxels down here, and then we can stretch it out. I want to work on level of detail next, where if you move out the voxels, we won't still render 130,000 of these things. We would increase the size of them over the brick map, so we would render less triangles and save more performance on the GPU. So there's all these little things you can do and all these things that I need to implement, but we just got to take it one thing at a time. So that's what I've been working on today, and there will be hopefully more work tomorrow. So I'll see you then. Thank you, and we'll see you then. Have a good one. Hello, ladies and gentlemen. It is September 18th, 2024, 9:06 p.m. I just keep working on this day after day. I'm at like 9-10 hours today. You just got to keep grinding. If you really want to become proficient at these kind of things, it just takes years and years of your life, and that's what I'm trying to commit. So I'm keeping a little scratch pad of all the notes that I take, and I can't even remember what I was doing today, so I was getting a little debug draw working for the vertex pulling. That was it. So you remember nobody cares, you won't know. I was working on vertex pulling last night, and I was trying to figure out how the shader worked from this repo that I was looking at. And so I was converting it to BGFX, and I took another crack at it today, but then I just got distracted because there's a version 2 of that binary greedy mesher that I love so much, and I incorporated it. I was trying to slam some of that code into my own project, and I got down to 800 microseconds for meshing an entire chunk. It was beautiful. It was amazing, but it wasn't rendering properly. And I spent like 2 hours trying to understand why, but I just needed to look at the vertex pulling because that was the primary thing that I was trying to do today. So I went back to the vertex pulling, and I was looking at all these. So if you remember, the binary mesher gives us 6 vertices. 6 vertices to draw, well, like 6 indices. 6 indices, 1, 2, 3, 1, 2, 3, to draw like 4 vertices or 2 triangles. And so we can take all of those vertices and put them into a single quad and then unpack that quad from the vertex shader, and that's called vertex pulling. And so I was working out the math in this little journal today, and so I figured out that I just needed to switch around these 2 binary operations to get the faces in the correct direction. and then I wrote like kind of a dummy draw function where I have my default shader program. And so I pretty much do exactly how, like, I simulate vertex pulling with this code, where I get the vertices back from the binary greedy mesher, and then I pack them in such a way where they resemble that vertex, that packed quad, and then I take them out again with this function that I simulated that would be on the vertex shader, and then I send them all through the regular draw function. And I can show you how that looks. We will need to wait for it to boot up, hopefully, if we don't have any errors. I need to get all the windows in place. Let me just disable all these regular draws, make these other lines go away. And so then I'll press V to summon a wall, and then I'll press it again. And so you can see that we almost have it working. It's flickering because it's Z fighting. It's like these meshes are perfectly overlaid along the Z buffer, and so that every frame when something moves, they're fighting for dominance. That's called Z fighting. And so I can just clear out that white stuff. And so now we're left with what is a vertex pulled brick map. We're simulating vertex pulling, but I don't think my code is quite right because there's a little mess up right here. And I was taking a look at it, but I just ran out of time today. Time is unfortunately limited. It's already 9 p.m. and we've gone through a whole day of work, and we've learned quite a bit more, but it's still not enough. But I did add a capability to draw the wireframes, and you can see that there might be some issue with greedy mesher. Maybe, I guess it's functioning as intended, but I don't know why it doesn't just combine these three Z positive faces right here into one. And I think this sticking out is just an issue with my dummy draw function. So if we did do vertex pulling, then it would probably work correctly, but I just need to debug a few more things, but it's almost working, but you can see that there's just a few more inconsistencies. What else was I doing? I made this dummy draw function. I was working on trying to get the binary mesher faster. I guess I didn't make that much progress today because I just ran into you spend a lot of time building up these systems, figuring out how to draw it. I heard Casey Muratori quote John Carmack, who said that time spent drawing is never wasted, and that's what I've been doing. I've spent time trying to draw the problem, and I've definitely learned a lot more about, especially the vertex winding. Like I made this like little dummy vertex shader right here. And so I was figuring out how the vertex winding worked. I needed to like switch around some of the indices and this flip lookup buffer. So lots of different stuff that you don't really care about, but that's what I've been working on, and it'll just take several more days, but eventually we will get there. Eventually we will have vertex pulling and a faster binary mesher, but I really need to take my time pulling this thing apart because it's the only way to truly understand how it works. And then if I want to add level of detail, where the terrain adjusts the further you go out so that you draw less triangles, then I really will need to understand this thing so I can add more conditions to draw a lower level of detail. And what I am doing right now, just as a little final demonstration, I will summon this big wall here. And so you see that it is in data, you can kind of visualize this as a 64 by 64 grid of axes, and each of these voxels is like one bit in that axis. And if you're looking at it through the Z positive direction, then it's going to be 0, 0, 0, 0, 0, 0, 0, all the way down until you hit that 1 and a 1. There's like a layer of 2 voxels in this big wall. So there's like a 0 for the padding, 0, 1, 1, and then a bunch of zeros. And so you can that's represented in binary. But I also figured that to help me visualize it better, I could just print it out as a tremendous wall of numbers, and that's what you see here. If I can zoom in on it. So you see that we have zeros on the outside, and then the inside is 6, and that's because in binary, 0, I don't know how, yeah, so 0, 1, 1, that's the number 6, represented. We're just seeing it in decimal base 10, but realistically, like if we could print this as a 3D array, you would see a bunch of zeros and then 2 1s at the end. But that's just the way I'm just representing 3D information on a flat screen just for me to understand. But for some reason it's rotated to the right, because if you can see on this brick map we have, oh god, I never disabled the Z fighting, but it doesn't matter, the video is almost over. So if you see, we have this invisible layer of padding, and then we go down one step, And then this is just one voxel. So 0, 1 is the number 2. And then we go down like another layer. So it's another 0, 1, 0, 0, 0. So you can see that over here, the 2's are over on this side. So for some reason, the way I'm visualizing it, it's like flipped to the right for me. So I don't quite understand why, but that's just the next step. I just need to really dig into this thing so I can really soup it out and customize it and really get the engine that I've been wanting to for the past year. And it just takes a long time. Several more days spent doing this, but I might as well document the whole thing. I didn't really have much to show. I really felt like a failure today, and I wasn't going to make anything, but the only way to... I'd like to have a document for this whole journey, so I just figured that even if I just spend a whole day shitting, you know, I'll just record it at the end of the day and talk about what I did. Like, hey guys, I just spent a whole day shitting, so just shat away my whole day. But I didn't do that today. I got a bit done, I learned a bit more, and that's really all you can hope for. That's really all you can hope for. And I hope you guys are also having a decent usage of your time, spending your days wisely, having decent days at least, and hopefully we have many more to go, and I will talk to you later. Hello, ladies and gentlemen. It is September 20th, 2024, 9:46 p.m. Usually I start these things right at the end of the day after I pretty much get too tired to keep working, and I'm too tired to keep working now, and usually when that happens I can't even remember what I was doing today. But I will try. Let me pull this out of the way. Let me open up my journal. So, I didn't make a devlog yesterday because I finally got my simulated vertex pulling working, but then I went to the real deal, and of course that wasn't working. But today I applied everything I learned from making the dummy vertex puller to the real vertex puller, and usually it's very helpful to... I didn't realize this beforehand, but simulating the problem will give you a very good idea of how to solve the actual problem, and that's pretty much what I did. So you won't understand any of this unless I show you, so that's what I'm gonna do. And so we're gonna boot it up, and it's gonna get very laggy because I'm also creating this big tool that I'll explain in a bit. But let me just create the binary mesh. Okay, so you see the mesh of a brick map. It's very large. We have the baked in AO, the baked in ambient occlusion, and I'll explain how that works in a second. But so you see over here, let me just turn this off. Okay, so this is the simulated vertex pulling dummy. So what we do is that I made another version of the binary greedy mesher, but instead of returning 6 vertices, which is 24 bytes, I return 8 bytes of data, which is just a whole face, and then the vertex shader will unpack it. But I made a dummy drawer, which will, in the CPU, unpack all that data manually and then plug it into a big vertex buffer, which basically does the same as just drawing all the vertices individually, but it simulates what the vertex puller shader would actually do. And so what I would do is that I would render it, and then I would render like the original functional thing. No, that just renders something else. I would render the, where is it? Yes, the draw packed vertex brick map. And so if there was something wrong, then I would see that there would be Z fighting and flickering. But as you can see, it's all perfect. It all perfectly lines up. And so then I can also enable the actual vertex puller. And so if I disable the other things, then you'll see that nothing changes, because what I'm doing is I'm basically overlapping 3 things at once. If I uncheck all 3 of these boxes, then you see that it disappears. But here I'll check the regular binary meshed brick map thing, and then I will click on the simulated brick map thing, and then I'll finally do the vertex pulled brick map thing, and then you see that they all look exactly the same. And if I were to change something, like, let me just how can I ruin this code real fast? Do we not have it open? Here we go. Okay, so let me just disable the AO, for example. So how would I do that? Where am I doing the AO? Let me just, yeah, so I will just comment that out real quick, and then we'll reload the shaders. And so then you'll see, oh, well, I need to enable the other draw things. Okay, so, no, God, please. Okay, no flickering, because the AO is on one of them, AO is not on this one. This was a terrible example. I am not good at doing this stuff off the cuff, but the only way to get better at it is just to do it. So instead, I'll just flip around, I'll just undo this whole other thing. So what I was doing here is that I was changing, depending on when the AO gets baked, you need to consider if you need to flick the triangles around. Okay, so now you can see Z fighting. So I fucked up the AO. So what really helped guide me is that I got the other renders of the same brick map working, and then I would overlay them. And so if I zoom in real close here, then you can see some very subtle Z fighting because the AO isn't baked correctly. I had to bake in the AO to the entire pulled vertex to get it right, where each AO on the vertex is just a color. It's just a color that we can shade the triangle with. And so what you need to do is that depending on the orientation of the ambient occlusion, you will need to change the way that you draw the triangles. So let me just undo that fuck up that I did. And I'll demonstrate where let me just turn everything off. And so I'll draw the simulated vertex dummy, and then I'll draw the wireframes instead. So now you can see the wireframe of this whole thing. Looks pretty cool, but you can see that on some faces, the triangles are switched around. So if I zoom in really close here, turn down the camera speed, so you'll see that the camera starts in the bottom left, the triangle starts in the bottom left and goes to the top right. But on another one, you'd see that it starts in the top left and goes to the bottom right. And that all depends on how the ambient occlusion is baked, because there's a thing called barycentric coordinate systems, where you need to determine the color interpolation of the triangle. I think if I disable all these chunks, it'll be easier to see. Okay, so yeah, so there is a coordinate system just for triangles between all 3 points called a barycentric coordinate system, and that helps you with color interpolation. You can't interpolate colors across this boundary on the triangle, and so the next best thing you can do is just flip the triangle around depending on the orientation of the baked AO. And I had to figure all this out. I had no idea before I started really tearing this whole thing apart, but that's the only way to learn. You just need to repeatedly fuck up and learn from your mistakes, and that's what I've been doing. And so now we finally have a correct version. We finally have a correct vertex pulled version that renders the exact same terrain with 1/3 of the memory cost, even though the binary mesh are already so for example, the original way I was rendering, I can show you the brick maps down here. If I do that's not the right one. I keep losing which is the right one. I keep adding more things to this, and it just turns into a huge mess. So we'll just disable we will disable the wireframe rendering. And so now you see down here that each face, in my old greedy mesher, I had like an X, Y, and Z, so that was 12 bytes. I had 12 bytes for color. I had like 8 bytes for textures. So basically, every single quad that you see here is 36 bytes. So times like, I don't even know how many triangles. Let's just let's see. 170,000, multiply 170,000 times 36 bytes, and that's like into, I don't know, might not be a gigabyte. Oh yeah, wait, we can see. So it's like 400 megabytes right now, which is probably not really good. Really not good if we want to render a lot of voxels all in this big dark void. So right here, we're still rendering a few triangles, but we're not sending as much data to the GPU because we pack all that data into like 2 UN32s, so we're saving a lot of memory. So I finally got that working, which is, it was just experimental, but I learned a lot more about barycentric coordinate systems, for example. But what will really help me going forward is that I still need to understand how the binary mesher works, and I've been doing that for the rest of the day. But then I had an idea, like where I showed you last time, how I printed out that big 64 by 64 grid of all the values in this brick map here. Well, I can just make an IMGUI tool that will actually display all the data to me, and depending on the way, I can select the different faces that I want to see this through, but IMGUI has a limit on how many things you can draw in the window, so that's what I'm going up against now. I'm pushing the very limits of IMGUI, but I can just show you when it first gets functional. So here we're looking at the Z plus perspective of the brick map, it's the same perspective that we're looking at this from. So you can see that it's increasing along the x-axis, and you can see that these numbers also increase along the x-axis here. And depending, I can change the perspective through which we observe the brick map with these buttons up here, but it's not quite working right because there's a lot to work out. And I just figured, like, well, it's already the end of the day. I can work on this more tomorrow, so I'll make a video now. But that is what I'm working on currently. And eventually the plan is, like, I'll be able to mouse over any brick map that you can see right here. Please, where is it? I keep losing it. So I can mouse over any brick map here, and so the plan is that I'll hook this thing up so that I'll just click on a brick map, and then I can pull up this little thing to manually look through that brick map at all the little voxel values just to help me debug if I have any problems with it. But this is mostly just an effort to really understand how the binary mesher goes through the data. So that's what I'm working on now, and it'll take a few more days. This thing will take years of my life, but the time will pass regardless, and at least I'm learning. So I'm having a good time. Hopefully you are too, and that's all I have for today, and hopefully there's much more to come. So I'll talk to you later. See ya. Hello, ladies and gentlemen. It is September 23rd, 2024, 8:37 p.m. Been working hard lately. It seems that the harder I work, the faster the time slips away. It is just horrifying, but you can't really think about it. So, to avoid thinking about it, let's think about something else. I will show you what I've been up to in my voxel engine. So, when I last made a recording, I was talking about how I wanted to get the time down for binary meshing. And so I was looking at the version 2 of the binary mesher, and they do it differently. They don't do ambient occlusion, which is what brings the time down, but I really like the ambient occlusion lighting. So I found that the way that they did it is they store an opaque mask whenever they generate the brick map or the chunk voxel data. And what that means is that you just have like binary data, like zeros and ones to represent if the voxel is filled or not. And then you can send that into the mesher program as kind of pre-generated data so that you don't need to loop through everything and generate your own data every single time you want to create a new mesh. And so that cuts the time in half. And so if I go into my little data thing and I'll start spamming this out, you can see that binary meshing for the test brick map, it's almost down into the microsecond range. If I keep spamming it, yesterday, okay, yeah, we got a 900 microsecond. Yeah, okay, so you can kind of see it every few times, but it's 995 microseconds. So last time I tested it, it was like 900 microseconds, but it varies between like 1.8 milliseconds and like 900 microseconds. So I'm pretty satisfied with it. I cut the binary meshing time in half, and we still have ambient occlusion, which is pretty good speed. So the next thing that I wanted to show you, I got that working yesterday, and so then if any decent voxel engine is going to have a thing called level of detail, where the further out you go, you'll see that the voxels kind of increase in size so that you render less triangles. And so I don't really have adaptive yet, but if I disable I was doing the vertex pulled thing. So here is the full-size brick map, and then I'll go down to half size, and so you can see that it kind of gets a bit chunkier, and then I can go to a quarter size, and then I can go to like 1/4 size, which just looks ridiculous. But you can still see the ambient occlusion, and it looks rather silly. But it's not actual size like the voxels we have down here. So that's what I'm going to be working on next. I'm finally going to be, well, no, that's not what I'm going to be working. That's one of the things that I'll be working on next. But what I finally want to do is that I eventually want to have voxelized entities, like characters that are entirely composed of voxels. And so in order to do that, I would need to have variable sized brick maps. But what I have right now are like power of 2 brick maps. Like this is 64 by 64 by 64. This is 32 cubed. This is 16 cubed. And this is 8 cubed. So even though you see 6 across, I still use padding on all the sides, but you probably get the idea. But what I want to do next is like maybe have like rectangular prisms of voxels instead of cubes, so I can like represent arms that are voxel data for like a character mesh. So that will be another challenge. But once I have that, that'll probably be the end of the latest research and development phase for the voxel engine. Then I can finally start consolidating everything and cleaning up all the code, because as it stands, I probably have 10,000 lines of code in my voxel test, and I haven't deleted anything, which is why it's so easy to show you all these things working together. But it's pretty cool, and I'm pretty satisfied with the level of detail. I store all the data. I basically create additional brick maps, and I store lower resolution voxel data. That can also help me for like maybe ray tracing or physics testing for like lower resolution for like maybe entities that are further away, so that the calculations aren't too intensive. So I am sacrificing memory for better performance, but that's one of the most fundamental trade-offs that you can make in computer science. You can either have more memory around so that you can do operations faster, or you can have slower operations for less memory because the operations would like generate all this data and then throw it away when they're done with it. So nothing but trade-offs, but modern computers have tons of memory, so I feel like I'm comfortable in making that trade. So we have faster binary meshing. We have like 1 millisecond binary meshing for these big chunks. I mean, we don't have caves yet, so it'll probably get slower the further we go. But 1 millisecond currently, very nice, and we have level of detail. And so I think just the final thing would be variable size brick maps, and then I'll finally start consolidating everything. And we can move forward. But as it stands, I'm rather pleased with the progress, and there will be much more to come, and that is everything I have for today. So thank you, and I will talk to you later. Hello, ladies and gentlemen. It is September 27th, 7:36 p.m. It is a Friday, I think. It's been a long week. I tried to get variable size brick maps working, where instead of 64 by 64 by 64, you could have a different X, Y, Z in every axis. And so I was trying to modify the binary mesher. And so I was making slow progress on it, but around Tuesday, the gum around my bottom left wisdom tooth got inflamed. I guess some food or bacteria got stuck back there. And so I went into the dentist on Wednesday morning, and they just said, hey, we can extract it. I mean, we usually just extract those things when you're younger. And so I'm like, well, fuck it, let's do it. And so they didn't sedate. They sedated me, of course. They gave me local anesthesia, but they didn't knock me out. And so I was conscious. And so it was pretty horrifying experience to be conscious as they stick a scalpel in your mouth, and then you can feel the pressure as they cut your gum open, and you can smell the blood, and it's just horrifying. And so they cut around, they jam some tools in there, and then they eventually just yanked the whole thing out. There was just this big bloody spike coming out of my mouth, and then they stitched it shut. And I am recovering. And Wednesday I spent the entire day in bed. I had a headache. I guess you get a huge headache when they rip a tooth out of your head. But I was completely bedridden. I could hardly get any work done. I maybe added some printfs to the variable mesher, but that was it. And then the next day I still had a headache, but I got a bit more work done. And today the pain is almost entirely gone. Of course I'm talking, and of course I feel a little pain, so I guess I should keep it short. So I thought I had the variable size brick map mesher fully working, but there are still just a few things that I discovered, because the final test with it was with voxelizing the Stanford bunny, as you can see right here. We finally have the Stanford bunny voxelized again. So this is using the variable brick map mesher function, but we still give it a 64 by 64 by 64 brick map. If I were to give it a 64x, 63y, 62z brick map, you would see a few holes in it. And I guess I can just do it for you right now. So I'll change that to 63 and change that to 62. And we will reboot. And it'll take a minute because it needs to recompile the DLL file, and I compiled it really poorly because I'm basically retarded at everything I do. And so you can see that there are some holes in it with the variable size brick map. So there are still a few issues, but the AO, the ambient occlusion, looks more or less correct. And the more or less voxelizing the Stanford bunny that you can see right here. This is the mesh that I'm voxelizing. It's composed of a bunch of little triangles, which I can show you right. Oh wow, okay, it actually, the voxels occlude, even though this bunny is in front of the voxelized bunny, it still occludes it. That's silly. But you see it's composed of a bunch of little triangles, and so we intersect those with the regular voxel grid, which is how we get this. But as you can see, there's still a few holes in it when I use the variable mesh. So there's still a few things to figure out there, but it looks correct, more or less correct. So that is what we've been working on. We almost have the variable size brick map mesh, and I will use that for my entities, and I can, if I finally get it working with like entities, I can do some crazy stuff in the engine, which you'll see in approximately like 10 years, because it just takes so long to do this stuff. But that's where I'm at now. Can I, God, I always lose that one button. But you can see that the Stanford bunny, the voxelized Stanford bunny is using like voxel sizes of like 1. So the voxels down here, which I think will be the actual size in my engine, are like a quarter of that size. So we're going to have to scale it down, and then even then we'll probably split up all the different limbs into little brick maps once we actually have variable size brick map meshing working. But there's still a few more things to work out, and that's what I'll be hammering out this weekend. as I recover from the wisdom tooth extraction. So, very silly week, but I'm still alive and I'm still working and we're still making progress. So, that is all for today, and I will talk to you soon. See ya. Hello, ladies and gentlemen. It is September 30th, Monday, 9:14 p.m. The month of September 2024 is almost over, unfortunately. Time just keeps passing, but we can't do anything about it. The most we can do is make the months productive, which is what we try to do every month, and this month has been no different. I've worked a lot on voxels. I tried to use GIMP earlier, but using the little drawing tablet is horrible with GIMP, so we'll just use good old trustworthy Microsoft Paint. So I will just in brief explain how my voxel system works. So if you can imagine, in reality it's 64 by 64 by 64, but let's just say that, just for example, because the axes will scale up, the dimensions will scale up regardless. So let's just say that we have a 2 by 2 brick map of actual, like, that'll store the actual voxels. And then we can extend it so that it's actually 4 by 4 by 4 if you count the padding on the sides. And the padding is strictly for the binary greedy mesher. When you organize all those voxels into columns, it's very helpful to call the faces by seeing if they're the adjacent brick maps next to it have voxels. If there's a voxel in an adjacent brick map where, you know, it could be stored in the padding, then looking at it from the positive X direction, you can say, okay, well, there is obviously a brick map right here, or with a voxel right there, so we can totally discard all the faces in that direction. So that's why we have padding. But when we want to mesh things together, when we want to like intersect triangles into this regular voxel grid, and you happen to overlap with some of the padding, it makes it rather difficult to calculate where the triangles, where the voxels should actually be calculated. So what my brick maps are actually composed of is they're 62 by 62 by 62, and then every dimension has a +2 for the padding on either side. And so what I needed to figure out was that depending on how a triangle intersects a certain brick map, you know, like this could be going through the padding over here. So I needed to design an algorithm that would calculate the offsets efficiently, depending on, like, that would like either do modulo 62 or modulo 64, depending on where it was in the x-axis, where it was in the y-axis. I needed to check all these cases. And we can just get that out of the way because I can't really explain it. It's far too late to explain it, and I moved the wrong window out of the way. Okay, so here's the actual thing. Let me just fumble around with this, get it out of the way. I don't care about the graphics tablet anymore. So we will boot up the little engine thingy. And earlier today, after I got it working, I was working with ray tracing. So you see that it's half opacity right now. And we are looking at a cube. But I didn't quite get it working because I use camera-based. The camera is the origin of the scene that I render. And so, of course, when I move it around, this cube is not supposed to move with it. This cube is supposed to be static. But this is ray tracing. I'm casting, every pixel is a ray, and I'm casting it into the scene, and where it's red, it doesn't intersect with the cube, and where it's green, it does intersect with the cube, but the problem is that the cube's moving around because I don't really have the camera-centered origin system set up correctly, but it does look rather silly, but I'll just disable that. So, oh yeah, and so of course, as soon as I click that, the chunk window goes away. So why does it keep going away? That is very irritating. Okay, so just to show you what I was explaining earlier is the voxelized Stanford bunny. And it took some time, but as you can see, this thing is just ridiculously huge. So huge that we can't actually show the whole thing, but just to give you a little idea of what it looks like, this is what the Stanford bunny looks like. Of course, we give a randomized color to every single triangle, but then we scale it up and intersect it with multiple brick maps, and you can see that you can actually see the triangles on some smaller level here. But this is composed of, God, I don't know how many brick maps? Like 400 brick maps that are all 64 by 64 by 64. I can increase the camera speed. But you can see that as we look along it, there are no gaps in the voxel mesh. There are no holes. I had to check like 7 different cases, like one where if we were outside of the X padding, if we were outside of the Y axis padding, if we were outside of the Z axis padding, the XY padding where you would see like lines missing, and then the XYZ case where you would see a single voxel missing. All of that has been accounted for in a rather efficient algorithm. It took a while to execute, but that's just because we were populating so many brick maps with so many voxels and then meshing it all together. We don't have multi-threading set up yet, but it would be perfect for a task like this. But as you can see, we have this tremendous voxel mesh. This is much larger than any entity I will actually show in the game. You can see that we can't even render the whole thing. That's what the black hole is for. I just don't render anything outside of a certain radius from the camera. But this is just the final test case for all that work that we've been putting into the voxel mesher. So now we can, any triangle mesh, an arbitrary triangle mesh of any arbitrary size, we can now fully voxelize in our engine. So this will be incredibly powerful if you want to import models and then like voxelize the individual arms or the heads, and then we can eventually rotate those around. But this is just the first step. That's what I've been saying forever. It's just these steps keep building on themselves. But we finally have voxelized entities. We were working on ray tracing, but it's not really a high priority. The next step is to get, if I can show my voxel, my little chunk window here again. Okay, and where is the origin? We need to find the origin, which is over here. So the next step is just getting all those binary mesh voxels down here into this actual voxel grid, and then expanding it out with multi-threading, and then we'll have actual terrain that we can add meshes to, little environments to, and then we'll get entities working. But first I want to clean up the engine a little bit. We've been doing a lot of experimenting and leaving a lot of messy code around, and even then all the include headers. I didn't realize this, but my pre-compiled header, my PCH header, I jam it into every engine and I include shit tons of stuff. I include tons of libraries, and apparently that slows down the compile time. I had no idea. And my compile time is relatively fast, but I want it to be near instantaneous, which I don't think is really achievable using all these engines. So the next best step is to clean it up as much as possible so I can speed up compile time as much as possible, and then get hot swapping working on a broader part of my engine so I can just instantly hot reload instead of doing what I'm doing now, or like I can just hot reload it, but it's much easier if I just close out and reboot it because I'm retarded and I didn't code the things right. So multi-threading, memory management, cleaning up the engine. There's a lot left to do, but then I can really start scaling up the voxel world. So that's where we're headed next, and of course it'll just take time, and we're working on it every day. And we are only making progress, so I'll show you more progress soon enough. Thank you for watching. See you later.